Okay, a quick little review of solving linear systems by elimination. We've got two examples here. These are directly from the lesson, but there was no video before, so we're going to do one now. And first one's quite easy. It's missing some of the early steps, but the second one will require a little bit of extra work, so we'll do both of these nice and quickly. So our ultimate goal is to get either the coefficients of x. In this case, the first one is 3 and the second one is 5. Okay, so equation 1, equation 2, right? Either to get them with the same number, or the coefficients of y, try to match them as the same number. And the coefficients of y in this question are already done. That's why this one is actually kind of done for us, and it's going to be a little bit simpler. Okay, and in this case, they have opposite signs, but that's fine. We don't need the signs to match up, and in fact, I bet a lot of people like it better when the signs don't match. It's a little bit easier to do some of the work in your head. So the whole point of this is to get those numbers lined up, the coefficients lined up, and then I either add the equations together or subtract the equations together. Remember when we first did this, it's a little bit weird to think about adding or subtracting equations, but it works, right? There's nothing wrong with this. We're not breaking any mathematical rules. It works. This is a strategy we use. It gets us the answer, so it works. And we add them together. It will eliminate the y's, and now I'll have an equation with a single variable. In this case, it'll be just x, and I can go ahead and solve that. And I can find the value of x. Once I've found x, I can use either original equation to find the value of y. So, so then you have to decide, do I add or do I subtract in order to eliminate the y's? Because that is the purpose. I want the y's to be gone. In this case, if I add, think about I've got a positive 2 and I've got a negative 2. And I'm going to either add them or I'm going to subtract them. And if I subtract them, 2 minus negative 2 is 2 plus 2, which gives me 4. And if I add them, that's 2 plus negative 2, which is 2 minus 2, gives me 0. So there's the one that I want. So I'm adding 3x plus 5x is 8x. 2y plus negative 2y is 0. So you don't have to write the plus 0, but that's what's happening. And 19 plus 5 is 24. So I end up with 8x equals 24. Okay, divide both sides by 8. That is not a 24. There we go. And x equals 3. We call this equation 3 just for clarity so that I can explain what I'm doing. But there we go. I found the value of x. That is the value of x where these two lines cross. Okay. In fact, let's take a look at this, just in case this little bit of extra visualization and understanding helps. So I've got 3x plus 2y equals 19. There's one of my lines. Okay, if I wanted to graph it without technology, I would change it to y equals mx plus b form, find the y-intercept, find the slope, and graph them, right? Or maybe come up with a bunch of points that are nice points and graph them that way. Okay, and then 5x minus 2y equals 5. So if we take a look at this, I'm just going to cut and paste this here, but it doesn't like it unless I do it off to the side. Okay, so here we go. Whoops. So if I take a look at this, is where these two lines cross. That's what I'm trying to find. And hey, look, the x value is 3. That's what I found. Now I need to find what the y value is. I can see clearly on the graph what the y value is, but sometimes it's not a nice value, and we're doing this algebraically. So how are we going to do that? Well, pick your favorite equation from the top one. I'm going to do equation 2, and I go 3 into 2. So I get 5 times x, which is 3, minus 2y equals 5. So that works out to 15, so I'm going to subtract 15 from both sides. And I get negative 2y equals negative 10. divide by -2, and I get y equals 5. I better get y equals 5 because we saw that was the answer. There we go. Now think about this. What if I had subbed 3 into equation 1 instead? Well, this point is on both lines. And what we're doing, this is what a relationship is. This is what an equation means. An equation is a relationship. It means that I put in the x, I can find the y that goes with it. I put in the x, I can find the y that goes with it. Well, at this point, both these relationships for x equals 3 have the same y. That's the point. That's what this all means, right? So for either of those equations, if I put in 3, I get the same y. I get 5 in both cases. What if I put in, is there a good example here? What if I put in 1? If I put in 1 for that equation, I'm going to get 8. If I put in 1 for this equation, I'm going to get 0. So I get different y's when x is 1. I get different y's when x is 2. I get different y's when x is 4. I get different y's when x is 5. I get the same y when x is 3, because that's the solution. That's the point of interception. So then I would say, therefore, solution, we always state our solution is x is 3, y is 5. We write it as an ordered pair. Some people like to write x equals y equals. No, we want to write it as an ordered pair because that shows we know it's a point of intersection. That's the standard of how we write it. Sometimes you're asked for a check, and if you're asked for a check, then you have to check in the opposite of the one you subbed into there, only in this last step. Okay, doesn't matter what you did above it, just down here. If I subbed into 2, I would have to check it in 1. Otherwise, my check is basically useless. That's the reason why we have to do it that way. Okay. All right. So I said I would do another one. Let's do this one quickly. Remember the first step. I'm looking at the coefficients of x and the coefficients of y, and neither of them line up. Okay. Neither of them are the same. 3x and 4x, not the same. 2y and 5y, not the same. So what am I going to do? Well, I got to do something so that they are the same. And what we're going to do is multiply. In this case, it's no easier to do the y's or the x's, so you pick randomly. We eliminated the y's last time, so how about we eliminate the x's this time? Just to show that we can. So what is a common multiple of both 3 and 4? This is like finding a common denominator, like that kind of thing. 12, right? So I want to turn both of those into a coefficient of 12. So I am going to do equation 1 times 4. So 4 times 3x is 12x. 4 times 2y is 8y. 4 times 2 is 8, and I call that equation 3. And I'm going to do 2, what am I going to multiply 2 by to turn it into a 12? Multiplied by 3. And so 4 times 3 is 12x. 5 times 3 is 15y, and 12 times 3 is 36. Now remember what we talked about before, how you have to either add or subtract, but in the last case they had the same, they had opposite signs, so we added, but in this case if I add 12x plus 12x is 24x. And some people would do that. They would do 12 plus 12 and they'd write 0 because they know it's supposed to be 0. But 12 plus 12 isn't 0, right? So you got to think about these steps. Make sure you understand why and understand what's going on. And then it's easy to decide what to do. Once you understand, everything falls into place. So I'm going to subtract. And I'm going to do 4 minus 3 just because if I look ahead at when I subtract the rest of them, when I subtract here and subtract here, I'm going to get positive numbers. It's going to be a little bit easier. If you did it the other way, you just have to be careful. Notice that you're getting negatives and it would still work out the exact same. Try it, it'll work out the same. 12 minus 12 is 0. There you go, elimination, gone. That was the whole point. 15 minus 8 is 7y. And 36 minus 8 is 28. Divide both sides by 7. And y equals 4. Okay, call that equation 5. I do the same thing. I'll let you finish this part. I take equation 5 and I sub it into either equation 1 or equation 2. I found the value of y where these two graphs meet. Now I'm going to find the value of x where they meet. So let's get rid of those two and let's just visualize this. 3x plus 2y equals 2. 4x plus 5y equals 12. There they are. There's their point of intersection. So 4 is the y value, and it looks like when we sub in, we should get -2. But take a look. That's the y value where both of those lines cross through the same x point. There's no other y values where they have the same x. It's just that point, and that's what this process finds. Okay, there's one other thing. If we go back up to these steps, and we did examples of these, so you could look at it if you wanted to. But the first step, so that we didn't see an example like this, you'd have to look at day 2 of this stuff to find an example. Put both equations in the same order. So you want, and this is the standard order we use, just makes everything, all the math, the easiest. X's, Y's equals number. So take a look. X, Y equals number. These were already done for us. X, Y equals number. What if one of the equations, see this one's A here and A here, so it's not quite right. This one's got, this is from when we did it in class a long time ago, right? This one's got a D equals number C, D number equals C. See, they're both out of order. So you'd notice, and you can look back at the example that's online, that's posted, to see how our first step was to, and I just erased it, but was to put them in the same order. And then you can do the elimination process. Okay, so there are some more complicated ones, but that stuff we're very good at, moving. Remember when we talked about this, just rewriting equations into different forms and moving things around a little bit of algebra, simple algebra. That's something that we should be pretty good at this point, so I think you'll be okay with that. Okay, so there you go. There's a quick refresher on solving systems with elimination.